Saxon Algebra 2, lesson 52. Don't let me fool you. I tried to write this as 51. We already did 51. It was about imaginary numbers. I loved it. Now we're doing lesson 52, and it is about chemical mixture problems. I know that some of you have probably already taken chemistry classes. Some of you might be living in fear of taking chemistry classes. It's kind of an intense game. Interestingly, my mother was a chemistry major in college for a while, and my husband studied chemical engineering for his undergrad. He worked in the field for 9 months and said, "This is disgusting, I'm leaving." And my mom decided she didn't want to live her life in a chemistry lab either. So they both changed careers, but they both had original passion for chemistry. So I'm not a huge fan of chemistry full on, but I like doing chemistry problems in math because it makes me feel really smart, and yet they're super easy to manage. So even if you think you don't love chemistry, or you have real life experience and you know you don't love chemistry, I'm encouraging you to give this a fresh chance because these problems are pretty controlled and limited, and I'm gonna make them so fun for you. You will love them. I'm also gonna break to you that what we're discussing today is called type A. Yes, there is a type B, as you might guess, but that's all. We're just gonna do 2 different variations on this problem, all right? So relax, enjoy, try to pretend that you don't hate chemistry or that you're thinking it's gonna be a delightful subject. And I'm gonna tell you what these problems look like, how we approach them. We get to draw pictures, so you know that's always fun too. I'm going to draw the picture first, and then I'm gonna read the problem and help you understand it. So let's just dive into the picture. In this scenario, we have a druggist, which sounds like something illegal. A pharmacist, right? A person who mixes drugs together. And he's working with iodine. We don't really know what that is. We don't have to know what that is. That's the fun thing about doing chemistry in math, is that we don't really need to know all the details of what things are. We're just playing around with the numbers. What I can tell you is that this is the iodine in the bin. It's a liquid thing. He's got some that's 10% strength, that's 10% iodine, and he's got some that's 50% strength, right? Chemicals like this come in different strengths. I don't know if you've ever noticed that. The problem is that he doesn't need 10% or 50%. What he needs is 20%. And if it helps you to write iodine here, we can do that. Okay, so what he's gonna do is he's gonna take some of the 10%, that's too weak, and he's gonna take some of the 50%, and he's gonna pour them together to create the 20%, which is what he needs for whatever. Again, we don't need to know. He's a chemist. He does things. We don't know what he's doing. All right, but we understand his problem because it's a Goldilocks problem, right? This one's too weak and this one's too strong. He needs something in between. But how much is he supposed to pour? Well, the other thing that we know is that he needs to end up with 100 milliliters of the 20%. Okay, that's useful to us. Excuse me, I took a drink of my water. Because at least we know what he's heading for. Now, this is a problem. We know what the ending goal needs to be. We know that we're gonna need 2 variables. One variable is going to be the amount of 10% that we add. And what John does is he has this clever little thing where he calls that amount P, which stands for pour. That's the amount we're gonna pour in of the 10%. This one, the amount we put in of this, he calls D for dump. We're dumping in that much. This clever little way of using 2 different verbs allows us to create 2 variables for our 2 different solutions without it feeling too random and confusing, right? I like these to go down. All right, so we're gonna pour in some 10% and we're gonna dump in some 50%, and in the end, we'll have this. Great. Now, what we need to do because we have two variables, we know it's going to happen. We're going to have to create a system of two equations that will allow us to solve for P and D. The fun thing is that they're going to look familiar to you. Remember, we're talking about systems of equations. We're trying to build a system of equations. And we've done that often before, and way back when we started, we used coins. Remember that? Where we'd have a certain number of coins and they added up to a certain value. That's what we're gonna do again. We're gonna make a quantity statement and we're gonna make a value statement, and then we'll use those two equations to solve. The quantity statement has to do with how much, not how strong, but how much. We know that the amount that we pour in plus the amount that we dump in has to equal 100 milliliters. So look how cute and easy that first equation looks. The amount that we pour in plus the amount that we dump in has to equal 100 milliliters. Fabulous. That's not so bad. And now you can see probably pretty quickly how this second equation is going to take shape. We're going to multiply by the values, the strengths of each one. Now, I could, just like with, let's do it this way. This is 10%, so I write 0.10 times the amount that we pour in plus 0.50 times the amount that we dump in will equal 0.20 times the 100 milliliters. Right? So all I did was I took this equation and I just multiplied it by the strength of each one. Oh my gosh, that was not bad. You have to admit, that was not too terrible. Understanding this is a little crazy, but now that you have it in front of you, you can recreate it. Okay, now the only thing I don't like is, what on earth, decimals? No, I don't want them. So just like with the coins, we can fix it, but we can also get cleverer about how we set these up in the first place. If I was doing this and you already knew what I was talking about, what I would do is I would just mentally adjust that decimal place over 1 as I wrote it. And I would write 1p plus 5d equals 2 times 100. See how I just mentally took out the decimal and made sure I did it carefully, right? All right, so now we have a system of equations that we'd like to solve. I propose we use substitution. I propose that we switch this into being p equals 100 minus d, and then I propose that we drop that in right there to our second equation. So we would have 100 minus d plus 5d equals 200. Straightforward systems of equations work. Once you get these equations set up, this problem is a breeze. The hardest part is getting this squared away and then setting up your equations, although that's not terrible. Now we're just off to the races. All right, we'll combine like terms. We'll subtract this 100. And we will get 4d equals 100. And we'll divide both sides by 4. And we'll get that the amount that we dump in equals 25 milliliters. All right? So that means we need 25 milliliters of the 50%. If you want, you can write this here. You can put the strength next to it, but it's clear that this is the D, and D relates to the 50%. Okay, so if that's the amount we poured in then, or dumped in rather, then we have to find the poured in. Just like any other systems of equations, we have to go back and make sure we get both answers. And we can see, here's a system, or an equation rather, that will help us. They have to add up to 100, so we can just quickly go, 75 milliliters of the 10%, because that is the poured, and that's the P. So there's our answer. And guess what? It's right. Yay. Okay, so once we get over the chemical part at the beginning, which, I mean, it's kind of fun. I hope it makes you feel smart. And we just have one more. works the same way. It's got a few little tricky wrinkles to it, but we'll sort those out. Look, it's my last page. Isn't that exciting? I think it's exciting. I love getting to the end of my book. Example 52.2. A chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. How many milliliters of each should the chemist use to make 1,400 milliliters of a solution that is 6% salt? Okay, so this chemical, I read you that whole thing and that was really boring and I bet you fell asleep or got distracted, didn't you? I would have if somebody would have read that to me. I would have been like, oh, I'm bored. I don't even know what that means. We're talking about a mixture of salt and water. Last time we were talking about iodine. We didn't really talk about what was with this iodine, right? If it's 50% iodine, what's the other 50%, right? We didn't really discuss that. This time, we're saying that we have a mixture of salt and water. By the way, in some circles, that's referred to as brine. Brine means salt and water mixed together. Now, we know that, I'm going to make a little table here. If it's 10% salt, then it must be 90% water. Another solution is only 2% salt, so we know that would have to be 98% water. We can assume there's nothing else in there. Okay? And then he wants us to make a solution that is 6% salt, so that would be 94% water, right? So John's given us enough information so that we can figure out the percentages of either the salt or the water. And when we set up our picture and have our percentage strengths, we can do it focusing on salt or on water. We can do it either way, as long as we're careful to use percentages that talk about the same element, either the water or the salt, we'll get the right answer. So we just have to be careful we're not mixing and matching these, which is pretty easy because these are all small and these are all big, right? So it's not going to be that big of a temptation to mix these up. But it's important to just recognize we can work the problem using the salt percentages, or we can work the problem using the water percentages. Both will give us the right answer. However, I would much rather use these cute little percentages than these big nasty ones, don't you? Especially considering knowing we're gonna have to multiply. I don't wanna multiply by those numbers. I wanna multiply by these. So we choose to work it using salt, and we'll be careful to always use these percentages and not talk about these at all anymore. But that's a choice we're making, all right? So when John talks about both parts of the solution, as he refers to them, we can sort this out and think of which one we'd prefer to talk about. All right, let's draw our picture. The picture is always the same. So we're gonna take one strength and another strength, and we're gonna mix it together to get another one. Now, you'll notice something about the way I draw these. The original amounts, I always put in square containers. This one, the new solution we're making, I always put into a pie plate with the tapered sides like that. It just helps me remember a little bit more carefully. These are like bottles on the shelf and this is what he's creating. I don't know, it just helps me visually keep straight that these two I can't change. This is the one that I'm making, all right? I also like to put the liquidy sign in here. It just helps me feel more in control of this problem. Okay, I also like how this looks like a happy robot face. It looked better before I put those in, but these look like the eyes and this looks like the smile. And I don't know if you guys are familiar with the band Daft Punk. That was really popular in the 2000s. It always looks like a little Daft Punk robot face to me, so that makes me happy. All right, so what John says is we're taking some 10% salt and we're taking some 2% salt, and we're mixing them together to make that much of a 6% salt. Notice how intentionally I set this up. I put the percentages inside the containers and I put the amount on the outside. Then I show myself pouring some of that in. I'm going to call that P for pour, and then I'm going to dump some of this in, and I'm going to call that D for dump. All right? I don't know how much I'm putting in, but I'm using those variables to represent it. Now I'm ready to make my equations, and I know the first one's easy. The first one's the quantity statement. The amount that I pour in plus the amount that I dump in has to equal 1,400. Now for my value statement, I just multiply these by their percentages. And I'm going to be careful. I don't want to write it with decimals. I'm going to be careful to write 10 times the amount that we pour in plus 2 times the amount that we dump in equals 6 times 1,400. Again, I'm taking this basic equation and hitting it with each of the percentages. I'm being careful to adjust those percentages. I know this is 0.1, 0.02, 0.06, so I have to bump it twice to get rid of the decimal. So this will be a 6, this will be a 2. This I have to bump twice, and so I get the 10. All right? So you can make those conversions in your head. Just be careful, because it's easy to mess this up. All right. This is looking good. Let's try, we could do elimination very easily here, but let's just do substitution again. I think a lot of students find that to be delightful. Let's solve for D this time. D will equal 1,400 minus P. I chose to do that because I would rather not substitute into this one because that's a bigger number. I'd rather substitute it here. It'll keep my number smaller. So that was my thinking. So I'm going to substitute this into that. And I'll have 10p plus 2 times, right, equals 6 times 14 is going to be 8,400. I did that by doing 6 times 1,000 is 6,000. 6 times 400 is 2,400. Add the 6,000 and the 2,400 together. It's not important to me that you do mental math the same way that I do. It is important to me that you do mental math in a way that gives you confidence. I share how I do it simply to give you more ideas. If we were sitting together, I would ask you, how do you multiply something like that in your head? What's your brain power? If you can articulate it, it helps you understand what you're doing. Okay, let's distribute this out. 10p plus 2,800 minus 2p equals 8,400. I'm going to copy this up to the top of my next page. 10p plus 2,800 minus 2p equals 8,400. I'm just going to check and make sure I copied that right. Yep, looks good. All right, what do you want to do next? Oh, I totally agree. Let's subtract this. Swim the numbers over to the right, and then we'll combine the like terms. That's gone. 10p minus 2p is 8p equals, let's see, we can just do the subtraction right here. Right? You can do that in your head, but I like to just do things like, it's easy to make simple mistakes, or at least for me it is. 8 goes into 56 7 times, so P equals 700 milliliters. That's our unit, right? It's a liquid unit. Okay, and then we go back and look at our problem. Oh yeah, the two amounts have to add up to 1,400. So we know that the amount dumped also equals 700. They have to total 1,400, not use that one for the answer. Okay, this is the right answer. Again, if you want them to be super fancy, you could put the strength of each one as part of the answer. But because we set up our variables cleverly, we know that P is the 10% and D is the 2%. So that's very clear. This is the right answer. John does draw the little diagrams like I do. He draws them exactly like I do. Look, see, can you see the little smiley face there? He uses a subscript. I don't bother with that, but you can if you want. But he does draw these little diagrams just like me. And it makes it so much easier to do the problem. So have fun with that. I know you don't want to be drawing a bunch of diagrams. You'd rather just get this done. I get that. But I also know that if you draw the little diagrams, you're more likely to get the problems right the first time. And then you'll be done faster. Yay, because that's our goal, right? Our goal is to make sure that you invest quality time in your math and then you move on with your life. All right, I didn't block off yesterday's either. Yay, we're done with the first week. Students who work with me locally, when we video chat this week, and I do want to video chat with you this week, we will do a review problem from 49, so be ready for that. We will also go over your midterm, and I'll just give you some, I'll show you what you did wrong and give you some thoughts on what you did right and where you need to shore up your work a little bit, right? But you both did really well, my local gents. So high fives, fantastic, nothing to worry about. I'm done. Goodbye.